Hello, my name is Mia, and this is my Lab 1 video report on constant velocity motion. In this experiment, we recorded and analyzed the motion of an object moving at a constant velocity using tracker software. I then created a computational model in GlowScript to compare real-world data with theoretical predictions. The goal of this experiment was to observe and analyze an object's motion at constant velocity, extract position time data from a recorded video, and compare it with a computational model. This lab is based on Newton's first law, which states that an object in motion remains in motion unless acted upon by an external force. Since we assume net force is zero, the velocity should remain constant. My experimental data, obtained from Tracker, closely aligns with the computational model, confirming that the object maintained a nearly constant velocity. Let's start by discussing how I collected and analyzed the motion data. For this experiment, let me restart the video. We recorded the motion of this roll of string moving in a straight line. The camera was kept stationary to avoid perspective distortion. There's a calibration thing here, 34 inches along part of the yardstick. And then I manually tracked the object's position frame by frame. You can see those as the blue diamonds where I clicked where the center of it was. And it recorded all of this data of position and then graphed it. And then I exported that to Excel and to generate a position time graph, as we can see here. And then we created the computational model to predict the motion using GlowScript, where we had this given to us, and then we put in our own data like here. And then when we run this program, we can see that, as expected, velocity would be constant. So the position would be moving and the velocity stays constant here. Comparing the experimental data with the computational model, I didn't put both graphs on the same thing, but as you can see, the position is going up in a pretty straight correlated, just like this one. This one is kind of not zoomed in very well, but it is going up like that, which means that the velocity is fairly constant. As you can see, the line of best fit, or I don't really know if you can see that, but it's sorry, highly correlated. So that zoomed out a lot. Some deviations from this, as are obvious because it's not a perfect line, is like human error in the tracking, because I had to do that manually and it was very tedious and prone to a lot of, because I had to do every data point, prone to a lot of different errors. And then there was also just a lot of complications with figuring out the tracker software in general. And then there's other stuff like outside forces like air resistance or friction that could have impacted it, but we're neglecting that in the calculations. So our model matching the data suggests that the forces acting on the object sum to zero, meaning no net external force influenced the motion. Okay, so to summarize, this experiment successfully demonstrated constant velocity motion. By analyzing real-world motion and comparing it to a computational model, we confirmed that an object in motion remains in motion at constant velocity when no external forces act upon it. Understanding constant velocity is crucial in fields like transportation, physics simulations, and engineering. Using automated tracking software and higher resolution video could improve accuracy in future experiments. Thank you for watching my lab report.